I'm Amélie Beaudet. I'm a paleoanthropologist from the University of Cambridge in the UK, and I'm also affiliated to the University of the Witwatersrand in South Africa as a researcher. And today I'm really happy to be able to speak a bit about our study of the brain of Littlefoot. So the main aim of this study was to kind of reconstruct the brain of Littlefoot and to compare it to extant humans, so us, but also to other fossil hominins, so which means all of the different species that are part of our family tree. Unfortunately, the brain cannot fossilize. So if we want to reconstruct the brain, we need to extract or to study the brain imprints that are preserved in the inner surface of the brain case. So it means that we need to get access to then the space inside the skull. So because of course we didn't want to damage this specimen, that is very, very important to us, we decided to scan the skull using a micro-CT scanner that is at the Evolutionary Studies Institute in the University of the Witwatersrand. And with this scanner that you can see here in the picture, so we could scan the whole skull at a resolution of 0.088 millimeters, which means that we could get images like X-rays of Littlefoot with the thickness for these images of about 88 microns, which is very precise, and this is why we call this method as a high resolution technique. So by using these images, we could reconstruct in 3D the skull of Littlefoot and also reconstruct the undercast. So the undercast is a replica of the inner surface of the brain case. And from the undercast, we could then estimate the volume of the brain. So it is about 400 cubic centimeters, so that's very interesting because it's the same volume as other Australopithecus specimens, so which is the genus of Littlefoot, and it's 3 times smaller than the brain of extant humans, so us. And what we could also see is that there are very nice brain imprints that are preserved on the undercast. We can see brain imprints that are known as sulci, which means the furrows that kind of delimitate the brain areas. And we could see also some imprints that were related to the vascular system. So if we look at this sulci, so the brain organization, what can we say about Littlefoot? So I could compare then the brain of Littlefoot with other Australopithecus specimens that are a bit younger, geologically speaking. And what I could see is that the brain of Littlefoot was a bit more primitive than in other Australopithecus specimens, and definitely also as compared to our own brain. And we can see that if we look at the front and the back of the undercast, and more particularly on the front, we can see that the broca's area, which is related to the language in extant humans, is very primitive in Littlefoot. And this is the same also in other Australopithecus specimens. And we can see that it's very different. It's more similar to the extant chimpanzees, which are closest living relatives, but very different from extant humans. We could also see that the back of the brain seems to be different between Littlefoot and the other Australopithecus specimens, and that potentially in other Australopithecus specimens this is more human-like, while in Littlefoot it is more primitive, so more chimpanzee-like. So that means that then the brain reorganized, we could see a reorganization of the brain after the time of Littlefoot. Then what about the brain vascularization? So as I was saying, we could see some brain imprints related to the vascular system. So here we could see that the pattern is the same between Littlefoot, the other Australopithecus specimen, but also as compared to Paranthropus, which is a genus that was living at the same time as the early humans. And also it's the same as in extant humans, so, which means that we have 3 main branches, the anterior branch, middle branch, and posterior branch. And so the organization seems to be the same with all of the different fossil hominins, and different from the chimpanzees because in hominins we have this middle branch that is not present in extant chimpanzees. So by combining all of this then evidence, what we could say is that the brain of Littlefoot was different from our own brain, and that much of the evolution happened after that time, so it means after 3.67 million years old.